Hi there. Today we're going to focus in on how the human eye operates, its parts, and how they function. And we also want to be able to compare the operation of the human eye with similarities and differences to a camera. So here's the human eye, and it's got several important parts as well. We'll look at what they do. So starting from the front of the eye, you have your first lens, which is called the cornea, and it helps to bend or refract light. Next, the hole in the iris, which is the colored part of your eye. So if you're brown eyes, that's your iris, the color of your iris. And your iris can cause light to, or cause the pupil, the hole, to get smaller or bigger. Then here's your big lens, and as you can see, it's got a curvature to it, so we would call it a convex lens, or converging, so it converges light or an image to the back of the eye. So your lens has muscles attached to it to help change its shape depending on how far or near we're looking at objects. We have at the back of the eye an optic nerve, which converts images to a nerve impulse to our brain. And then this yellow part is the retina, which has rods and cones to help focus color and black and white. As I said earlier, our eye is very similar to how a camera works. Here are the similar parts. A camera at the back has photosensitive film, and the equivalent to the film in a camera would be your retina in the eye. The image is upside down in a camera and your eye. Cameras have lenses, just like you have a lens. Cameras have an adjustable diaphragm to let more or less light in. Our iris does that for us. So our pupil gets bigger or smaller because our iris acts like a diaphragm. It can cover the hole a little bit more to let less light in, or it can make our pupil look bigger to let more light in. Also, our eye has a sclera, that's the outer wall. It's hard, just like a light box. Has a cornea, which is the eye lens, and another second crystalline lens system. A retina, like the film, iris, like the diaphragm, a pupil, like the aperture in a camera, and an eyelid, like the lens cover of a camera. I talked about the back of the eye, which is the retina, and if we zoom in and we blow up what the retina looks like, we can see all these things. On here are rods and cones. Rods and cones. Rods and cones are responsible for helping us see light. Colored light versus black and white light. Here's a more detailed picture. The liquidy part of our eye is the vitreous humor. It's interesting, right here where the optic nerve comes into the back of the eye, that's called our blind spot, which I'm going to speak about in a few minutes. Here is how our eye works, like a pinhole camera. We see the image, it's focused on the back of the eye, and it's upside down. We have a little bit of liquid here between our lens and the cornea, and that's called the aqueous humor. So again, iris is like the diaphragm. It adjusts how much light comes into the eye. Sclera is like the hard part of a camera. Retina is like the film of a camera. We have an eyelid, that's like the lens cap, I guess, of a camera. Here it is again: lens, diaphragm, iris, sclera, and then retina. I talked about this before. There's a blind spot where the optic nerve comes into the back, and therefore there is no retina. So if we look at an object and we force it to focus exactly on the blind spot, it will disappear. So for example, if you look at the spot here, okay, you can find that it will eventually disappear at a certain distance. That's because what you're doing is you're focusing that object directly onto this part of your eye, the retina, where there is no retina. And the reason there's no retina there at your blind spot is your optic nerve has to come in there. Let's look at the brain pop clip on how the eye works.
Ooh, old-timey photographs. How much? $5. Well, you got it. I don't believe this is the only costume you had left. Dear Tim and Moby, how are our eyes able to see stuff? I don't get it. Sincerely, Fausto. Well, believe it or not, your eyes work kind of like a film camera. Light tends to move in a straight line unless something reflects it or bends it. When light hits an object, it bounces off and is reflected into your eyes. Your eyes have their own light-bending parts called the lens and cornea. The cornea is the outermost part of the eye. It collects all the light that's bouncing off of objects and focuses it through a small hole. That's your pupil, the black spot we all have at the center of our eyes. The iris, or colored part of your eye, opens and closes around the pupil, depending on how much light there is. If it's dark, the pupil will open up wide to let in as much light as possible. Whoa. Right behind the pupil is the lens, which focuses light onto the back of your eyeball. The lens is clear and curved, and it can change its shape depending on what you're trying to focus on. It acts a lot like the lens of a camera. The back of the eye is coated with a special layer of tissue called the retina. The retina is kind of like the film in a camera. It's covered in photoreceptive nerve cells. Oh, photoreceptive just means they're sensitive to light. Anyway, there are two kinds of photoreceptors on the retina. You've got about 6 or 7 million cones and more than 120 million rods. Rods are very sensitive to light. In fact, they can be triggered by a single photon. The cones are less light sensitive, but unlike the rods, they can detect color. No, I am not posing for color pictures. So the lens projects an image onto your retina where the rods and cones transform the light and color into electrical impulses. These are transmitted up your optic nerve and into your brain. There, your brain decodes the image, and that's how you see. Right, there's another way the eye is like a camera. When a camera lens focuses an image on film, it winds up upside down. And when the lens of your eye focuses an image on your retina, it also turns upside down.